Hello, everyone. Welcome to our webinar on the usage of knowledge graphs and ontologies in real life. We will start in a few minutes to give everyone a chance to log on. In the meantime, before I introduce the speakers, here is some practical information about the webinar. At the bottom of the screen, you will find a chat window which allows you to contact our team during the webinar if you need to. You will also find a Q&A button in which you can ask questions for the Q&A session at the end of the presentation. We already received a lot of questions by email. We will try to answer as many questions as possible. However, if your question has not been answered, you will be able to get a response after the live session in a one-to-one chat or email. So please don't hesitate to send your questions. I think we are ready to start now. Let me introduce the speakers. For this, I will just share my screen. So with me today, it's a great pleasure to welcome with me Anthony. He will share with us the state of art of ontologies and knowledge graphs from a Gartner perspective. Matthieu Parmentier is in charge of data governance and applied AI for media production and distribution at France Télévisions. He will give us feedback on the usage of knowledge graphs and ontologies in real life. And myself, Sebastien Urios, head of new business development at Perfect Memory. Thank you again for attending this webinar. I will let the mic to Anthony. Thanks, Anthony. And now the floor is yours.
Thank you, Sebastien. Let me just get... Okay, great. Okay, thanks. My name's Anthony Mullen. I'm a VP analyst at Gartner, and I lead our AI agenda. It's a pleasure to be with you today and talk a little bit about ontologies and knowledge graphs and explore why they're a foundational approach for intelligence and decision-making in your company. You know, natural language automation and AI project approaches in many enterprises reminds me of the folk tale of the frog in water. You can put the frog in cold water and keep raising the temperature degree by degree until it comes to a terrible end. Actually, reminds me of a news story today. But it also reminds me of the adoption of AI in organizations. Business units have been acting independently, taking a tactical approach and deploying solutions for narrow use cases, some metadata here, a recommendation engine there, a customer persona project, a content management refresh, or a bunch of chatbots. Now, this approach gets things moving quickly, but you start to build up a technical debt or a cognitive debt even, getting yourself into hotter and hotter water. I would say that the majority of organizations I see today are in this position, building a siloed approach to modeling intelligence. And this ad hoc approach to modeling topics and concepts means that we end up with little reuse. Everything is proprietary and bespoke, and we lock ourselves into a landscape with thousands of vendors where the technology is shifting rapidly. And this creates limits on how intelligent your organization can be and how fast your organization can respond to change. You only ever have pockets of intelligence scattered across the organization. In truth, it's a mess of metadata, and that costs us time, money, and opportunity. So what to do? Well, There is a class of technologies that can help us reduce this cognitive debt and serve as a foundation for modeling all the topics and concepts that your organization cares about. And it's the focus of this webinar today with Perfect Memory. Those technologies are ontologies and graphs. You see them down here in the bottom with the orange surround. And what you're looking at in this diagram is what's called a Gartner hype cycle that shows how technology progresses from inception right through to being productive. Now, this is the 2021 version of the Natural Language Technologies hype cycle, and the 2022 version will publish any day now. And what you will see is ontologies and graphs, the focus of this webinar today, moving towards the slope of enlightenment and beginning to provide real value to many. But what are they? And how exactly can they help? Ironically, relational databases are not the best for discovering relationships. They're good at relating tables to tables, but not data elements to data elements. And these many-to-many relationships, which are present everywhere in your business and in the world, are still very challenging to model in relational database management systems. This is where ontologies and graphs come in. This is a diagram of a simple knowledge graph, Bob and his holiday to France. You can see the relationships of Bob with people, places, and things. Using knowledge graphs allows us to model both explicit and inferred relationships with the connected data. So explicit, Bob is interested in the Mona Lisa. Implicit, Bob is interested in the works of Da Vinci. Simple but powerful. And knowledge graphs can be used to query complicated questions and obtain comprehensible, actionable answers, including logical reasoning, machine learning, and rules management. Organizations like Google, Facebook, LinkedIn, and Amazon are all knowledge graph enterprises, and so should your business be. You can see in orange here this new layer of abstraction that ontologies and graphs add on top of our traditional relational database schemas. And we use them to model the concepts and things we care about, such as customer behavior, movie themes, product attributes, intents for chatbots, and on and on and on. As artificial intelligence and language automation projects proliferate, which we looked at earlier, data, content, and architecture can become chaotic, with concepts and models and metadata scattered across the business units, implementations, and vendors. Domain ontologies and knowledge graphs are major AI methods to represent knowledge that is human readable, standards-based, using things like OWL and RDF, and as a result, easily shareable, reusable, portable, and abstracted from the underlying storage mechanism. Let's have a quick example. Uber Eats wanted to improve their recommendations for a pool of 300,000 restaurants and menu items based on user preferences. They created a graph of users and dishes and a graph of users and restaurants. And the new graph-based approach improved on all of their previous models and gave them a 12% boost in accuracy. And as a result, better engagement and click-through rates. One aspect of graphs that can help is their ability to support query expansion for search. On the left, you can see a small piece of the ontology used by Uber Eats. And on the right, you can see a user searching for Tantan noodles. It's near lunchtime, getting hungry with this talk. But there is no restaurant selling Tantan noodles near the eater's delivery address. Instead of returning 0 results, query expansion, based on the knowledge stored in the graph about how dishes and restaurants are related to one another, enables us to retrieve and rank more results associated with these expanded queries, such as Szechuan, Chinese, and spicy food. On the back end, the original query is expanded to similar queries, and relevant restaurants from the expanded queries are first retrieved, then combined, and then ranked before being surfaced to the eater. This way, we always have something relevant to show the user. No dead ends. Graphs are full of useful patterns to support insights about employers, employees, customers, and systems. You can see here 6 examples of the algorithm types we can run against our graphs to discover useful information. We have the graph, but we need to be able to query it and do computations upon it. So let's go through them with some use case examples. So the first here, centrality. Identify important nodes in the graph. This could be used to identify fraudsters in an advertising ecosystem or influencers that you should target for marketing. It could be for discovering pivotal content or page ranking or optimization of process flows. Community detection. This is where we partition the graph into sets of nodes which share similar properties and characteristics. We use it for customer segmentation, fraud analysis, discovering dangerous interactions between prescription drugs, or even finding duplicate records. The third, shortest path, can search for the shortest paths in different ways between concepts or even places. For example, to create a low-cost tour of a travel destination. We see pathfinding, sure, be used in transportation and logistics, but it's also used for internet marketing, such as website promotion, thematic traffic, contextual advertising. The fourth, similarity algorithm, and that compares a set of nodes based on the nodes that they're connected to. 2 nodes are considered similar if they share many of the same neighbors. We use this again for recommendations or comparing 2 people's preferences and likes. Fifth, connectedness. How many nodes do I need to remove to break all nodes or relationship connections from A to B? We use this in communications, analyzing network behavior, network analysis, influencers, and so on, relationships between content. And then finally, graphlets. How many occurrences of shape X are present in the graph? And we can see behavioral patterns that we might have missed in our users. So as you can see, there are many use cases here we can support when we model the domain via an ontology and express it via a graph. By 2023, graph technologies will facilitate rapid contextualization for decision-making in 30% of organizations worldwide, perhaps yours. Let's recap on the benefits of this approach to AI. Ontologies and graphs give us better integration between disparate information systems and heterogeneous infrastructures, consistent labeling for AI projects where ontologies act as a canonical reference, broad application to use cases, reduction of technical debt and lock-in to vendors, and finally, more performant AI systems using composite AI, where we take the best of semantic approaches, ontologies and graphs and taxonomies, and mix them with computational approaches such as neural networks and statistical machine learning. Okay, some recommendations. First off, be agile. Don't boil the ocean. It's tempting to get lost in the project of building mega graphs from day one. You don't need to model the entire knowledge of your business to get started. You can begin with one use case at a time, sometimes called creating a minimum viable graph, a bit like a minimum viable product. Start with applications that bring enhanced customer experience or an employee experience. And solutions and vendors in this space are often the most mature. Check what already exists for your industry. Work with ontology vendors to see how they relate ontologies or definitions to graphs, the expressions of these ontologies as data. These are a major accelerator to get your initiative off the ground. And there's a lot to choose from these days. Ensure easy read-write access to data for software engineers and data scientists. Create UIs for knowledge workers to engage, to create and calibrate the knowledge. It's an enterprise-wide affair. Use machine learning to reduce maintenance and development of the graph. Machine learning is complementary to these technologies. Reduce technical debt by steering master metadata initiatives with ontologies. And finally, counter employee churn and retiring experts by giving them interfaces to express the knowledge they have about your business. We're seeing the great waves of resignation now across many different industries, and we can use these tools to capture really useful knowledge. There's many more things that we can do with graphs. We have another couple of sessions coming up. And with that, I'd like to thank you for your time and hand you over to Sebastien.
Thank you, Anthony. So thanks for the enlightening presentation. I will share my screen. Just a minute. Yeah. Okay. Just to make a quick introduction on about what our solution does. So basically, the process described by Anthony seems to be a long drive. And what we have achieved at Perfect Memory is that we tried to industrialize and we provide a unique solution that helps organization to use those knowledge graphs and ontologies off the shelf. So our products basically collect any type of data, any type of content from your IT ecosystem, thanks to connectors, standard connectors and business connectors off the shelf. And then we proceed on it, semantic analysis, to understand the meaning and the context in which data and content is used. We turn it into intelligible concepts, thanks to the usage of ontologies that help us to reconcile data from the different data silos, heterogeneous data. And then we reveal invisible links and information, thanks to knowledge graphs, that give us the ability to cross and deduce things which mechanism is called inferences. And then we can provide to end users the ability to navigate across the knowledge and have a 360 view of the data of the organization. To do so, we use the combination of three technologies. The first one is semantics. The objective is really to interpret data and content to understand the meaning and the context. It is also a user-oriented approach. At the beginning of the project, we create an ontology which describe the different concepts and relationships between these concepts in the business language of the organization. So it's not to users to adapt to the tool and the information system. The machine understand and speak the language of the users. So it facilitates a lot the navigation across knowledge. The second technology we are using are knowledge graphs. Those knowledge graphs give us the ability to deduce invisible links, invisible information that was not accessible previously. It gives us also the ability to cross information between internal information and external information, because we are using the W3C standards, such as RDF, and we are able to import public information that is stored into the linked open data. It's like an equivalent in the semantic world of Wikipedia, but there is more than 500 websites that provide public information on every topics, and you don't have to put into your system known information. We will retrieve it automatically, and it will be automatically compatible and operable with your data. And those knowledge graphs, as explained Anthony, gives you also the 360 view of all your data and this navigation. And the last technology we are using is artificial intelligence in the broad way, I mean, deep learning, machine learning, etc., which help us to proceed what we call intelligent document processing, the ability to extract information from documents and understand the meaning of this information to generate automatically metadata into the knowledge graph. So our platform really industrialize all your initiative about ontologies, semantics, and knowledge graphs, because it has off-the-shelf several capabilities such as semantic workflows, business rules inferences, automatic metadata generation, fast and accurate search, and AI orchestration tool that give you the ability to deploy new projects starting from scratch in few weeks. And it's also really easy to integrate into your current ecosystem. Our system can be put on top of this the existing information system thanks to our connectors. We can connect to any type of information such as data lakes, repositories, cloud, etc., etc. And it provides also high interoperability and intelligibility of your data. So the three main benefits you will get from it is, first, it accelerates a lot the delivery of your data and AI projects because this platform is available off the shelf and it's fast for deployment. It helps your users to take intelligent decisions because they have a 360 view of all data, and also thanks to business rules, we can provide insights, alerts, etc. automatically, and also it provides the activation of your business knowledge to preserve, structure, and make it available for all your users. There are three macro use cases in which our platform provides value. The first one is all about data management. Each time you need to reconcile, to structure, and make accessible data from different data silos and mix heterogeneous data, content, and structured data in the same referential, our platform helps our clients to take intelligent decision and find new use cases that generate revenue. The second one is all about content management. Thanks to intelligent document processing, we analyze and we extract intelligence from multimedia content, videos, pictures, PDF, etc. And we generate automatically metadata from all the information that are invisible. And for instance, we will analyze what's in the video, the sound, the colors, the people, etc., and generate automatically these metadata that make for end users the capability to find the exact sequence they were looking for into all their video legacy or content legacy. And the last one is about knowledge management. We all know that us humans as employees, we create a lot of knowledge every day. And to do so, we create Word files, PDF files, PowerPoints, etc. that we store into SharePoints, folder directories, etc. And we all know that most of the time, we are not able to find this specific information we are looking for. So what we provide in this situation is the ability to process and interpret all the documents and make it available again through a power search in context to give it for all the end users. And at the end of the day, what do you really get from it? So first, you take real advantage of your data because you can access all your data in context really quick. And not only data scientists, but of course, end users, because most of the time end users cannot access their own data. Secondly, we preserve the knowledge. We structure it, we make it available in a really user-oriented way so that a new employee don't need 6 months onboarding to understand all the procedures and all the storage and mechanism of the new company is just joined. The third one is about new revenue generation. As soon as you can cross data, you have new use cases and new opportunities to generate business. And the last one is about intelligent decisions. As we provide the full pictures to decision makers and end users, they are able to take enlightened decisions. And this is really new and really important in our current world. And last thing, we are perfect memory. We are hidden semantic technology provider. We work in several industries. We have a lot of clients in sports industry, in telco companies, retail, media industry also. We are more than 15 employees, and the product is available, has been available for 4 years in production and has been developed for 10 years of R&D. And now I will let the mic to Matthieu Parmentier, one of our clients, who will explain us how he uses every day our platform to solve his different problems. Thank you. It's up to you, Matthieu.
Thank you, Sebastien. I will share my screen and control the few slides I've prepared for you. It's okay. You can see
okay.
some. It's okay. So I work for France Television, the French public broadcaster. I met Perfect Memory a few years ago when I was in charge of innovation project and when the product was in development. And now I'm leading the AI factory of France Television, which is a department from the IT department of France Television, where we are really focusing on data. So France TV, in a few data, this is how I can summarize the company. So a lot of linear historical channels from the national one, the most renowned one, and also some other tiny channels like the radio and the TV we have overseas on all the overseas French territories, but also 24 regional channels and a lot of digital offers, especially summarized here by 4 main brands we have for the youth and the educational and the cultural offer of France Television. So the story I want to quickly summarize for you is that when I've been told to set up a data and AI department at France Television 2.5 years ago, we had a lot of silos from like in every big old companies, and these silos were decided to meet on the data lake. So I would say a perfect balance of centralized and decentralized architecture at the same time, but which was creating the opportunity to join the data into a single space. So this was at that time 2.5 years ago a major challenge for the IT departments to centralize this data and also to make them interoperable for future use. And we focus on the merge of the data that has some value. So the data which has the most value in television, these are the data that circulate from one system to another. So from HR, financial silos, but also from program, news production, sports production, and so on. The other challenge of this centralization of data was the number of unstructured data, because we are television. So unstructured data at our scale, it means audio, video, and subtitles. So all these data are really unstructured, and that was also a major challenge for us. But we focused first on the data that are probably the most important for us, the data regarding the programs we are broadcasting, we are editing, and producing, shooting ourselves also. So what we did right after this concentration, by creating this single entry points, thanks to a few conversion and merge on the several data models, that we create this ontology and this knowledge construction upon our data. So that was the second aspect, the second round of our big project, creating the graph, the knowledge graph structure, which offers, as it was just said right before me, that was offering a 360 degrees view around the data that are collected with our programs. So we had to transform the raw computer data into networks of information linked to real concepts in the company. So that's what we call the entity view, because, as you know, when a historical channel like France Television goes from a pure channel-centric approach, where the most important brand is the name of the channel, the linear channel, and now we are moving to this program-centric architecture, where a program can be viewed first online and then broadcast on one channel or another one in another territory, and then come back for a long replay career on the digital platforms. And we have now also plenty digital platforms everywhere. So these life cycles are very complex now, and that's why this project was good to conduct at that time, because we were at this big change between the channel-centric architecture and move to the program-centric, the entity-centric architecture. And as Sebastien just said, the DAM, the data asset manager from Perfect Memory, is really entity-centric. So this was the good time for starting to build our ontologies and our knowledge graph with these data. So the platform was built like that, and now the most difficult part of the construction was to enter the reality of our business into this knowledge graph. So this schema here, I can show you, is the TV program life cycle from the ID right on the left, the ID of a program, to the production, the scheduling, the broadcasting, and at the end you got the archiving events. So as you can see, there are a lot of actions, and these actions, they happen in a given order, but most of these actions and these orders are potentially asynchronous. So that means that our system has to cope with the different task ordering. And yeah, it never happens the best way every day. You have a lot of exceptions every day, and your model has to be very clever to adapt to the fact that the timeline could not be respected and the different events could happen in a different order. But at the end of the day, when we turn that into a schema and proper ontology of our France TV use case, we had the possibility to store all our data respecting this schema in the semantic web storage of the Perfect Memory product. So all this allows the immediate use of our data, even if the level of granularity and the quality of the data could differ from one service to another, but it completes the model in a nonlinear way over the time. Finally, we are now, so I show you what we did with the perfect memory interface. So you can show, you can see here our data shown in the context visualization that we chose. From the very first beginning of the project, it took 6 months for us to set up the whole system and put it into production. But these 6 months, they really include a major onboarding of the collaborators and especially the data teams, especially the data engineer, data scientists we have already in the team at France TV, because I had to make them understand the major benefit of graphs and ontologies, because they are data people, but they are not really keen on graphs, and that's new for a lot of them. So it took some time to onboard them, and especially to underline the major benefits, at least not everything, but the major benefits. And I would say that now the same project should be set up in 3 months. And by the way, we are actually initiating a second perfect memory use case, which is not in the range of the metadata describing the programs like the one I show you here. The second project we are just starting is about easing our news indexation process. So all the archiving news projects. And we plan to set up this second project in 3 months. So this perfect memory platforms, that really accelerates our ability to deploy new business services and end users application. That was the core motivation for us behind this choice. And yes, this is thanks to the data centralization, but this is also thanks to this interoperability that has been created and set up around the setup of the whole ontology. So now we know that any kind of knowledge we have stored in the graph is ready to drive a workflow or to be combined, transformed, or published without renewing anything. With the traditional databases we are using before, anytime we have a new business services to create, usually there is something to deal with the database itself, because the data we want are not placed at the right time. They can't be requested with the sufficient performance and so on. So there is always something that needs us to renew something in the storage or even in the ingest of the data. Here, with this ontology and this semantic knowledge storage, any kind of data has the same property, rank, value, and is available the same. So we can really welcome new use case and just answer the people that bring their use case to us that, okay, it will be possible. Here are the data, just navigate on the interface, pick up the data you want to create your perfect service, and then it's very easy to build a service after that. So in summarize, as a summary, I could really say that after now 1 year of exploitation of this project, it's really a key accelerator for the digitalization of our system, for the achievement of the program-centric transformation, and also to allow us to respect the technical roadmap. So we invested a lot during the first year to set up and accelerate and put that into production. But now we are very happy to add some new side project. We are building at France Television, for many reasons, our own AI processes. And today, Perfect Memory is the orchestrator of all our AI processes, because by all the data that are seen here, Perfect Memory is able to take the decision if we need or not the AI enrichment we can provide. And after the AI enrichment we are doing on our side, then we push back the data into the knowledge graph, and then we have this data visualization that appears here. You can see some shot segmentation, advertisement points, scenes segmentation. Everything is done by AI, but it's orchestrated and data visualized in the same tool. So yeah, here is in conclusion what I could present you today as a major use case for us, and as also as a happy client of the solution.
Thank you, Matthieu. So now we will move forward for the Q&A session, and there are several questions that have been put in the Q&A box. Marie, you had a question about the time to create and manage knowledge graphs and ontologies. I think that Matthieu just replied. He said that the second project took 3 months. Can you just share us perhaps the time for the ontology build itself? How much time did it take for you to build this ontology at the beginning?
The main difficulty we had was because we were taking data from several systems. So every data was coming with their format first, different formats for sure. We had only a few data that was already semantic. So this one was very, we were happy to have them like that. But most of the other was classical key value data coming from several departments. So what took the most time, it was to interview all the system owners to know the context where this data was typed, entered, and how we can put them in the ontology with the right context around. And so that was not really the work done by Perfect Memory. It was a business work done by ourselves, which has now a big benefit because all this knowledge is shared and also documented. So we know where we go now, and it offered us the opportunity to discover some data that was still entered in 2 different systems, but sometimes having different values. So yeah, that was a good journey. In any case, that was a good thing to start this project because we discovered a lot of ourselves.
Okay, thank you.
Right after that, it was, let's say, a few weeks, 2 weeks, 3 weeks to set up the ontology.
Okay,
but, yeah, maybe 2-3 months of interviews.
Okay. And that makes me switch to another question of Tariq, and it is for you, Anthony. He asks us, how do we reconcile your first recommendation to start small with the warning you gave at the beginning regarding failures, siloed and fragmented approach?
Yeah, thanks, Tariq. You know, starting small doesn't necessarily mean starting uncoordinated. So we can start small, but in a coordinated way. What I often see in organizations is each project or each department taking their own approach to, you know, AI training data or metadata management or vendor sourcing and so on, and that gets pretty complex quickly. So, for example, if you were building up a knowledge asset in the contact center, you don't need to cover every possible topic, you know, all products, all attributes of products. Maybe you begin with the returns process or something like that. So yeah, start small, but in a coordinated way. And maybe just to add a little bit more to that, you know, there's lots of AI tools and engines and algorithms that you can, that different departments and different developers can use. And actually, it's fine for people to use different solutions and different algorithms. What isn't fine is to create siloed approach to information architecture. Yeah.
Okay, thanks, Anthony. And another question for you. Yeah, can I take an ontology from the web as is to fit it to my business?
Yeah, that's a good question. There are a lot, of course, there are increasingly more ontologies out there, and that's part of the, you know, the attraction, of course, as well. But what you'll often find in practice is that they sometimes need cleaning up. And there are vendors that, you know, work on this specifically. So yes, you can pick up an ontology from the web as is, but they aren't all as clean and well formed as one another, which is why, you know, companies like SciBite, for example, in the life sciences, they offer services to provide this sort of a cleaning up. So, yeah.
Okay. And by the way, at Perfect Memory, we are using meta-ontologies that are specialized for a specific client. So, for instance, in the media industry or in the sports industry, we have created meta-ontologies that we will provide in the next weeks as open sources that you will be able to use into your projects. And then we, thanks to the workshops that Matthieu just described, we specialize this ontology and we inherit from the common properties and the common concepts from the macro ontology. This is also a way to accelerate your ontologies and knowledge graphs projects. And Matthieu, I have another question from Tariq. It's tricky, but did you consider alternatives other alternatives than Perfect Memory when you try to find a solution to your problem? And if so, what made you choose this one versus others, except of course that we are French together and we can speak in French?
I'm working in a public company, so every kind of solution we buy is through a European transparent process. I wrote a RFP, and after that, the concurrent offers from Perfect Memory was, let's say, big Legos, able to build a tool that were doing the same need that the one covered by Perfect Memory. So it's something where I can centralize, share my data, and create workflows from this centralized data, and at the end also to data visualize any kind of additional metadata. So that's what I showed you. But at the end of the day, you have a product on the Perfect Memory shelf, and the other concurrents had all a Lego. So building the Lego instead of set up the product gives a very, very different price at the end of the page. So among all other considerations, classical versus ontologies and semantic versus traditional databases, because I was keen on this knowledge graph management. So that was my first also intention. The price was the king here.
Of course. Yeah. And another question for you, Anthony. What are some of the innovations in this space? Are there some new initiative in this space?
Yeah, I mean, I certainly, to counter a lot of the technical debt we see, and also the missing intelligence, semantic tools like ontologies and graphs have really came forward. Now, I think one of the earlier questions was, how much effort is it to actually create these things? And historically, there was a certain amount of effort. I think the most exciting things that I'm seeing in this space, and it looks like we saw that in the case study today, is combining the different techniques. So combining, for example, large language models or transformers like GPT-3 and BERT with that taxonomies, ontologies, and knowledge graphs. So using the best of bottom-up approaches, if you like, using the large language models, neural networks, with the best of the top-down. And in fact, connecting the two is interesting as well. I have also seen the use of, some use of things like hypergraphs, which give you a much more looser relationship between concepts. And in the synthetic data space, I've also only once seen mention of synthetic graphs. So, of course, to strip out maybe personally identifiable information or risky or information to create synthetic counterparts of graphs. But I think what's most exciting is using the best of semantics and the best of sort of computational and neural networks. That's a really powerful combination that in truth was only really started in the last 2 to 3 years.
Yeah, exciting. And now, last question for this Q&A session. Yuri asks us about, at a low level, what graph database are we using? So it's I will make an answer. So we have a premium partnership with Ontotex, and it is integrated into our solution as an OEM layer. And we've been working with them for years, and we also, our R&D teams are working together to increase the performance and also the accuracy of the knowledge graph database mixed to our semantic engine. So this is really what we are using for all our clients, and it provides a lot of benefits to them. And I see that a last question is entering. It's about the France TV use case. So the question is, would you see similar benefits of ontologies and graphs for service providers who use various tech stacks and platforms to provide services for content owners and broadcasters? I don't know if Matthieu, you want to answer this one.
I'm rereading it.
Okay.
I can maybe fill in if you want. All organizations, I think, can benefit from this approach to modeling concepts and topics. If you are working with a variety of different organizations as a middle aggregator position, then you're inherently dealing with lots of folksonomies from a sort of data and concept modeling perspective. So it would be useful from a sort of aggregation point. Matthieu?
I see benefits everywhere, but actually, for example, we are working a lot on the recommendation algorithm or that sort of things. And as far as we need to qualify the artistic intention, and so we are far from the media, the audio, the video, and so on. We are more about the context of ideas, and this is also where there are room for connections. So there are room for knowledge graph. And potentially also, because I'm in charge of AI, the actual big new landscape for AI research is the fact to make deep learning directly on graph. Actually, deep learning is mature, but on data which are structured and or unstructured, but not graphs. So now we are a lot of emerging solution for AI training and deep learning with graphs. So that's my humble opinion, the new landscape also for the next generation of AI services.
Okay, thanks, Matthieu. We also see on our side a lot of emerging projects and needs from clients about data preparation. And we really see benefits by the usage of knowledge graphs in this way, because it accelerates again the AI projects and the data science projects, because as soon as you have defined your ontologies, which describe your business rules and links, you only have to map your data to the ontology, and the platform is ontology driven. Most of the work is done, and then you only have to navigate through your information, enrich it, and you can plug easily new data sources. It's versatile, it's agile, it's scalable, and really, really quick to deploy. Do you have one last word, perhaps, to conclude this webinar, Anthony?
Yeah, expand your thinking in the AI space from sort of short-term tactical approaches and look more strategically. Algorithms are a commodity, but your information architecture is for life.
Thank you, Anthony. So I really want to thank you for attending this webinar, and it's been a great pleasure. Of course, if you have questions that you get in mind, don't hesitate to send us by mail on our website, and of course we will forward it to Anthony and to Matthieu so that they will be able to reply. Thanks again. Have a great day and see you soon into our webinars. Thank you very much. Bye-bye.